Hello everyone, a very warm welcome to yet another video of the introduction to our programming video series. Since last two videos we are discussing about a conditional statement, how we can able to write a conditional statement in our R program so that we can bring in some kind of a flexibility in our program execution. So we learned about the if-else statement, and in this video we are going to talk about a loop concept in programming. Loop is also another important concept in programming, so we're gonna see that what exactly that loop is all about. Then we are going to discuss the basic structure of the loop, how the loop looks like in R. There are two types of loops that you can do when you want to work with a for loop: a looping by index or a looping by value. So we are going to discuss about what the differences of these two approaches. So now let's get started and let's see what this loop in programming is all about. Now loops are used to repeat a section of a code. Okay, that is what loops does. Loop repeats a specific section of the code, and it repeats the section of the code with the help of a counter. So you have a counter, or you have an index, and that index gets incremented by 1 every time the loop executes the code, and once it reaches to its end position, the loop will stop executing. Okay, this is how it works. And in this loops there are further two types. Okay, you have a for loop and you have a while loop. Okay, now in for loop you use a index or a counter. Okay, so in for loop, for for loops, a code repeats itself as it works its way through a counter. Okay, and once counter reaches to its last position, the for loop stops. But in while loop you have a condition. Okay, you have a condition, and when this condition is false, when this condition becomes false, then for loop exits. Okay, then for loop exits. So for the then the while loop exits. So let me repeat it again. So in the for loop you have the counter or the index, and once the counter reaches to its last position, the for loop will exit. In while loop you have a condition, and once condition becomes false, the while loop will exit. So depending upon how the loop gets executed, it has two types. Okay, for loop and while loop. So in this video we are going to talk about only for loop. In the next video we will discuss about the while loop. Right? So let's go and let's have a look at the basic structure of the for loop in R. So let's understand the structure of for loop. So this is how the structure of for loop looks like. So you have this keyword called for. So this is a keyword. Okay, then you have a loop index in, this is also keyword, and a loop vector. Okay, so this is within the brackets, and then you will have to use a curly brackets here, opening curly bracket and the close one, and within the curly brackets you write the code that you want to repeat. Okay, so this is how the structure looks like. Now what is this loop index? So loop index is a placeholder. Okay, loop index is a placeholder. Now what it does, it points to the values of loop vector, or it points to the index position of values in the loop vector. Okay, this is what this loop index does. And loop vector is a vector of values used inside a for loop. Okay, now all these values, whatever the values you are going to put in the loop vector, will be used inside the code over here, right? And how these values are called? These values are called with the help of loop index, either pointing directly to the values or pointing to the index position of the values. Okay, so if this sounds very confusing to you, let's take a simple example and let me try to make this concept a bit more simpler with the help of that example. So let's see the example now. So here you go. In this case, I am using a simple vector called myvec, okay, with some values, with 4 values, and I am using a for loop. Okay, but inside this brackets, I am going to show you what exactly the difference lies in looping via value method and looping via index method. Okay, so the chunk of code that I put within the curly braces is the same. So the output you are going to see on the console will be the same, but the method of deriving that output will be different. That will be based on how the looping is calling the values from the my vector. Okay, so now let's understand this closely. First, by the way, if I compare this example with the structure that with the structure that we have seen of the for loop, then here in this case I represents loop index, okay, and my vec represents loop vector. Okay, right? Now let me explain to you what exactly is going on in this looping via value and looping via index case. So let's first try to decipher looping via value concept. Now here in this case, looping via value means loop index, so iteration and value of I, and here you have a value within the print function. Okay, so let's see the first iteration. Now when the for loop starts, when the for loop initiates, I will have a value of 1. Okay, that's by default, and the I will now going to point to the value of my vector. Okay, that means I will now going to point to this value, which is 0.4. Okay, and this value will again be used inside the for loop. So the output of the first iteration of the for loop inside the print function will be 0.8. In the second iteration, when this first iteration completes, the second iteration, I is now going to point to 1.1, because it's simply pointing to the value of the my vector. So it will point to 1.1, and it will then be multiplied by 2, and the value of the print and the value inside the print function will be 2.2. Likewise, for iteration 3 and 4, I will point to 0.34. Twice of this value will be 0.68, and in the last iteration 0.55, and twice of this value will be, I think, I think it's 1.10. It's 1.10, right? So this is how it is, and by the time this I reaches to number 4, there would be no value to point at, right? So 0.55 is the last value of the my vector. So when I reaches to 4, there will be no value to point at, and that's why after R reaches to 4, the loop will exit, because there is no fifth value to point at, right? This is how looping via value is calculated. I is pointing towards the value. Now let's see how the looping via index calculates the values. So again, I will use the same table, iteration, value of I, and value inside this print function. Okay, now the first iteration. Now in this case, what is happening here is, let me use the different color. I is pointing to the index position of my vector. Okay, that means I will have a value of 1 to length of my vector. Okay, what is the length of my vector? What is the length of this vector? It's 4. So I will have a value of 1 to 4. So in the first iteration, the value of I will be 1. Okay, and now what is happening here is that if you go to the print function, then I will going to point at the first value of my vector. So this is what it means, that pointing, looping via index, the first index value, this one of my vector. And what is the first index value of my vector? It's 0.4, and then it's going to make the calculation of 0.2 equal to 0.4. It's going to multiply it, will make 0.2 twice, and then it will give you the answer as 0.4. Can you see the difference now? Here value of I is 0.4, but here the value of I is not 0.4, it's 1, but it's now pointing towards the index position of the my vector, the first index position of the my vector, and that value is now getting calculated, is getting used in the calculation, and the answer is 0.4. So the answer here is the same. I'm sorry, this should be 0.8. Okay, this should be 0.8. So the answer here is same, but the way of deriving the answer is different. Okay, similarly for the second iteration, so this will be the second iteration. The value of I will be 2 from this vector, from 1 to 4 vector, right? The value of I will be 2. Here in this case, now I will point to a second index position of my vector. What is the second index position of my vector? Is 1.1. So it will be 2 multiplied by 1.1, and the answer will be 2.2. In this case, both the cases the answer will be the same. Likewise, you go for 3, you go for 4, and once the I reaches to 4, the last value of the loop vector, once it reaches to the 4, the last value of the loop vector, the for function will now exit. Okay, the for function will exit. So the iteration 3, let me finish this table. Iteration 3, the value of I will be 3, here will be 2 into my vector pointing to the third value here, which will be 2 times 0.34, answer will be 0.68, same answer. And at iteration 4, the last iteration, the value of I will be 4. In this case, it will be pointing to the 4th index, so 2 multiplied by 1.1, 2 multiplied by 0.55, and the value of I will be 1.1. Value of the print function, will be 1.1. So did you get it now? As you can see, the value of the output is the same here. Output value is the same, but the way it is derived using looping via value and looping via index, the way the function calculates the value, the print function calculates the value is different. Looping via value, I is simply pointing towards the value of my vector. Looping via index, I is pointing to the index position of my vector. In this case, I is acting as a placeholder in looping via index construct. So having understood these two different types of using the for loops, let's open the R session and let's find out how we can able to use the for loop with the help of a bit of complicated example. Okay, so let's open the R session. So here is the R file for the for loop. Now the first one is using a print function. We have already seen this example. This is looping via value example. Okay, so if I execute this, then I will get the output as 0.8, 2.2, 0.68 and 1.1. This is what we have seen. In this case, I is pointing directly towards the values of this my vector. And second chunk of code is looping via index. So this also we have seen. In this case, the I, it's pointing, it acts as a placeholder. It's pointing to the index position of my vector. Okay, so if I run this command, you can see that in both the cases the output is the same, but the way it is derived is different. Now comes a bit complicated part. Now here is a for loop that I've created. Now let me tell you what exactly I'm going to achieve out of this for loop. Okay, so I've created a list here. Okay, this list is called as a foo. Okay, and it has 5 elements. The first element is a simple vector of numbers. The second element is a matrix. It's a 2 by 2 matrix. Third element is also a matrix. In this case, I've created a matrix of boolean values, true and false, with 3 rows and 2 columns. The fourth element is simple. It's simply a string. It's a text string. And the last element is again a matrix, but the matrix consists of all the string elements in it. Okay, so this is the list. Now what I want to do is I want to first find out what element of the list has a object type matrix. Okay, so I'm going to find out which element of this list belong to the object type matrix, and once I find out that, then I want to extract some additional information about that matrix. For example, how many rows it has, how many columns it has. Okay, right? And that I am going to do with the help of for loop. So this is how the problem is set up. First, find out whether a specific element of the list is a matrix. If it is a matrix, then find out some additional information of that matrix, number of rows, number of columns, etc. Okay, so now the first thing I will be doing is I will be creating a name object, and I will be copying all the names of this list in the name object, okay, with the help of names function. So if I run this, then you will see that the list been created. Here is the list been created, and all the names of the elements of the list is stored in the names vector, in the name vector. Okay, so after that I will be creating the object called is.mat. I'm going to fulfill that object with the help of inAge. The number of length of the foo I will be using as the number of inAge. Okay, so I'm going to use a repeat function na, and length of foo, the number of inAge that I want. So if I execute this, then you can see that since the length of foo is 5, the length of the list is 5, it has filled na.mat with na 5 times. Okay, then I'm going to simply initiate nr. nr is another object which is number of rows, nc is number of columns, with the help of is.mat. So whatever the inAge that I've created in is.mat, I'm going to use the same inAge and going to fill na, nr and nc with those inAge. So in a way that I'm initiating these three objects with inAge. And finally I'm going to use another object data.type. Again it will be initiated with the values of is.mat. Okay, and then I'm going to enter into the for loop. In for loop, I is a loop index. Okay, and in this case loop index I is used as a placeholder. Okay, it is pointing to the index position of the list, right? It is pointing to the index position of the list, and that each of the position of the list I am storing into the member object. So for example, when the loop will start for the first time, the value of I will be 1. So in member, all the content of the first element of the list, which is A, will be stored into the member. Okay, and now I'm going to use the conditional statement, if else statement. Why? Because now I want to check whether that particular member belongs to the object type matrix or not. If it belongs to the object type matrix, so I'm using a function is.matrix. I'm checking the object type here, and the outcome of this is.matrix will be a boolean value, true or false. Okay, once it is true, then the code within the if statement will get executed. And what that code will tell me? That code will tell me some additional information. Okay, now if is.matrix is true, then this will be yes. Is.mat will be yes, because then this is a matrix, so I'm plotting this as a yes. Then the first value of nr, which we have initiated with inAge, the first value of nr will be filled by the number of rows of this matrix. Okay, similarly the first value of nc will be filled by number of columns of this matrix. Okay, and data.type, here I am coercing the matrix into a vector. Okay, so I am now coercing this member into a vector. Remember, the member is a matrix in this case, but I am coercing it to the vector, and I am writing or copying that values into a data.type. Okay, this is what this for loop does. This is what this if statement does. And if this is.matrix number is false, that means the element of the list is not a matrix, then the else part of the statement will get executed. So So in this case, is.matrix will be replaced with no. Okay, and I'm storing all these values. In a data frame called bar. But here I am using string as factor equal to false, which allows me to not transform the string values into the factors. They will be used as a string values and not as a factors. And then I am printing the values bar to the console. So this is how the for loop looks like. Now let's execute the command and let's see how the bar data frame looks like. Okay, so let me execute this. So here it is. As you can see, the first element of the list is A. Now AA is not a matrix, so is.matrix is no, because then it has gone to the else part of the loop. So that's why no is printed. Similar way, because it's not a matrix, the value of NR and NC are NA. Remember, we have initiated NR and NC as NAs. So the first value will be NA and data.type will also be NA because it's not a matrix. Go to the second value of the, element of the list. Second element of the list is BB, which in this case is a matrix. So is.matrix is yes. That means this code, this part of the code is getting executed, because now this statement is.matrix member is true, and therefore the statement within the if bracket, if condition gets executed. Okay, so is.matrix is yes. Number of rows, it will calculate the number of rows here with this small piece of code. Number of rows in this case is 2. Here you go, the number of rows is 2, number of columns is 2, and what is the data type? Data.type is an integer. Remember, it is coursing, it is changing from matrix to a vector. Okay, and the type of the class of that vector is integer. That's what is printing over here. Okay, similarly it goes to CC, the third element of the list. It's also a matrix. It's giving me some additional information of that. And finally the fourth element in this case is not a matrix, so that's why you can see values of NA, NR and NC are NAs. Data type is also NA, and the last element of this list is also a matrix. So this looping or repetitive nature of the code can only be possible with the help of for loop. Okay, I hope you understood now where exactly the for loop is used. In this case, we have to use a for loop because we have to iterate over the entire length of the list. Okay, and in this for loop we have used I as a loop index as a placeholder. It's pointing to the index position of the list and not actual value of the list. So these are the two things to be noted. So let's quickly recap what we have learned in this video. So we started the video with the help of asking a basic question: why the looping is required. Looping is required if you want to repeat a specific piece of code in your program. Okay, then we saw there are two types of loops that are used: for loop and while loop. In this video we talked about specifically about for loop. Then we understood the basic structure of the loop, how the loop structure in R looks like, how to create a loop in R. And then we touched upon important concept of looping via index and looping via value. That means where the loop index is pointing at. Is it pointing at the value of the loop vector, or is it pointing to the index position of the loop vector? In that case, it acts as a placeholder. And then we created a small example in our session and we run the for loop onto that example. Okay, so this is it. Thanks for watching, and if you are finding a value out of these videos, then you may like to subscribe to my YouTube channel, Infinity, a channel for data science. You can also hit the bell icon so that the moment I publish the videos on the YouTube, you will get immediate notification. Thank you very much and see you. Bye bye.